Alright guys, so we're going to be taking some notes today. In our notebooks, right, we're going to be opening these up to our next available page. So my next available page today is going to be here. You should have already completed your one pager. Should be glued. I have mine glued in here, right? But that's what it should look like. Okay. We talked about weather. We went through heat in the atmosphere, temperature, air pressure, wind, and moisture. If you did these sections in a different order, that's okay. It's all good. What we're going to be looking at next is understanding fronts. Okay? So you're going to be copying this into your notebook on your next available page. So when we're understanding fronts, I'm going to zoom in here so you can see this a little bit better. We need to talk about specific things regarding moisture in the air. Right? So if there is moisture or water vapor in the air, and warm air meets cold air, condensation occurs. Okay. This is going to cause or causing precipitation or rainfall. Pretty basic to understand there. Next thing you're looking at is kind of how these things work, right? So we're going to draw kind of a cloud here for my basis, right? I'm going to have line going this way, line going down, and this is my moist, warm air. That's going to be pushing in, going that way. Okay. Then I'm going to have my another mass here. That's going to be my cold air moving in. Where they meet, I'm going to see that condensation in the form of clouds, right? Maybe storms, all depends. Next two things I need to really talk about in my notes. Okay, I'm going to move up here. If you needed to pause the video, feel free to pause the video. Next thing I'm going to be talking about down here is I'm going to make a T-chart for it. Right? So I've got my line, and I'm going to have a line going down. I need to talk about low pressure and high pressure. Low pressure and high pressure. When I'm dealing with low pressure on maps, it's going to look like a circle with an L in it for low pressure. When I'm dealing with high pressure, that'll be marked with a capital H. Lower pressure, that warm air rises and meets cooler air. This is going to bring rain. In higher pressure cells, there I'm going to see heavy, right? So heavy cold air is going to sink and warm up. And there, the weather I'll see will be clear skies. If you need to pause at any part in the video to get these notes, go ahead and do so. But I'm going to go ahead and move on. Okay? So again, if you needed to pause or go back, do that. I'm going to move on. Next thing I'm going to do is open up my notebook page, so I should have 2 pages kind of like this. Okay. I'm going to be creating 2 separate areas using 2 T-charts. Well, they're actually going to be kind of squares, not T-charts. Excuse me. So what I'm going to do is I'm going to take my line, right, with my ruler. I'm going to go on one side and kind of cut that in half. Going all the way down. I'm going to do the same thing on the other, finding the middle and going all the way down. Then I'm going to find the closest to the middle I can line and go all the way across. Right, and do the same thing on the other side, going all the way across. Okay. So we have created 1, 2, 3, 4, 5, 6, 7, 8 squares using 2 pages. This one was page 45 for me. This was 46. Okay. Next thing I'm going to do is I'm going to talk about what this first block is going to be. That is going to be my cold front notes. So I'm going to write cold front right there. Down here, I'm going to include an occluded front. I have a warm front over here. And then lastly, a stationary front. The way these notes are going to look is I'll have a picture on these sides and then my information over here. So let's start with cold front. I'm going to zoom in there. Again, if you needed to pause the video, pause the video. When I have a cold front, the thing I'm going to be looking at is I have an air mass moving in, so I'm going to draw that. Then an arrow, kind of big, pointing which direction it's going. And I'm going to take a blue color just so I can see it clearly. And I'm going to make sure I know that that says cold, okay? My cold front moving in. There is air over here in this space, right? That air is going to be pushed up. This warmer air is going to be pushed up. Because warm air is lighter than cold air. When that happens, when that warm air gets pushed up, clouds are going to form, right? Clouds are going to form, and we'll see some rain maybe, depending on how moist the air was. Okay. So that's my picture for a cold front. Going over here to my notes, I need to write some information about cold fronts. Okay. First thing to know is that they are faster, faster cold air a faster cold air mass runs into a slower warm air mass. When that happens, the denser cold air, that denser cold air slides under the lighter warm air pushing the warm air mass on top of the cool air mass. That weather that we're going to see right? Because that's important to know. The weather we're going to see when this happens is clouds and heavy precipitation. Okay. I'm going to go through and highlight some important words that you need to make sure you have down. Okay. So we have cold. Ooh, I really hope this doesn't smear. Actually, I'm going to wonder if there's a better way to do this. Looks like I need to use my handed under yellow color pencil. Right? Need to know about the slower warm air. Slides under. We need to know about that. That lighter warm air. Pushing the warm air mass on top of the cool air mass. And then again, my weather is important. That stands out to me. Weather and heavy precipitation. We're going to move up to an occluded front. Again, if you needed to pause this video, make sure you've paused if you needed to. So I'm going to talk about occluded fronts next, since they're right here. Okay. With occluded fronts, they are the most interesting weathering pattern. They're very complex. They're very complex creatures, occluded fronts. Okay, move the camera so you can see it a little better. Okay, occluded fronts, very complex. So for that, I'm going to start off by drawing one front here. Then one is going to meet it here. Okay. With occluded fronts, it's important to know the direction this front is moving in. Okay, so this right here is my direction. Little note for myself, so when I look at my model here, I can understand what's happening. Next, I'm going to draw my cold air mass. That's moving and pushing my cooler air around. Okay. Do another thing there. It stands out a little bit. What happens when that happens is this wasn't here originally. It pushes in. So as it pushes in, it's forcing this warm air we're going to see above here up. Okay. So it's going to be pushing that warm air we see up here up and out of the way. That'll go on either side of those. Where that warm air is, we'll see clouds forming and lots of rain. Okay. So again, changing my color just so I can see it. Warm air is up here. My notes for this one, occluded front, is kind of interesting, right? Remember, it's the most complex front. What happens there is that a warm air mass is caught between two cooler air masses. When that happens, the dense cool air masses move underneath the lighter warm air mass. Pushing it above them. As the warm air cools, it's going to condense, right? Because warm air, as it cools, condense. We know that from the water cycle. It condenses. Oop. Right. Weather we're going to see, that's important. The weather we're going to see here is going to be clouds and precipitation. The reason we write precipitation instead of just something like rain is because depending on how cold this air is, it might be snow, it might be sleet, that varies, but those all fall under the word precipitation. That's why we write that one there. Okay, I'm going to go through and add things that should stick out to us, things that we absolutely need to make sure we get. We need to understand that it's very complex. Okay, that warm air mass is caught between two cooler ones. That dense cool air mass move underneath the lighter warm air mass, and it's going to push it above them both. Again, that warm air cools and it's going to condense. And lastly, the weather we need to care about are clouds and precipitation. Okay, move on to the next one, where we're talking about warm fronts. Okay, so we talked about a cold front already, so now we need to talk about warm fronts. They're kind of the opposite in a way. So where instead of a cool front moving in, we're going to be having that warm air, right? I'll go ahead and just write it in red. That warm air is going to be moving in, right? Move up a little bit. That warm air is moving in. And what we're going to see is that cold air kind of running away from it in a way. When that air moves away from it, you're going to see it being pushed kind of like that in a slope. You're going to notice clouds forming all around this little bow area. These are really longer clouds, is where you see with warm fronts. And then, of course, where there's clouds, if enough of it condenses, we're going to see precipitation. Okay. Very heavy precipitation, rains for a lot with warm fronts. Or excuse me, very light precipitation, just rains for a long time. Okay. Our notes for these is that we have fast warm air mass overtakes a slower cold air mass. That denser cold air, right, causes the lighter warm air to move above it. The weather we're going to see here is going to depend on something. So if we have warm air that is humid, what we're going to see there is light rain or snowfall. If that warm air is dry, there's not a lot of moisture in it if it's dry, what we're going to see is scattered clouds. going to go ahead and move forward. Oh, hold on. Need to highlight my words. Almost forgot. So I have that fast warm air overtakes a slower cold air mass. That denser cold air is going to cause the warm air to move above it. The weather I'm going to see is either going to be light, if it's humid, right, it's going to be light rain and snowfall. If it's warm, it's going to be dry, then I'm going to see scattered clouds. Next one is stationary front. Almost done. Woohoo! So with a stationary front, they're really interesting. So think back to our plates moving, right, with those transform faults where they just kind of slide past each other. Fronts do the same thing for stationary fronts. They are stationary. They are staying still. Those fronts are going to stay together. So when that happens, the way I like to draw it is I just have two fronts that just kind of touch a little bit. Okay. I have one that is my warm air. No arrows because nothing's moving. And then one that is my cold air. Okay. Where they meet, where they touch is going to have lots of big clouds. So I'm going to draw a really big cloud. Okay. Where that big cloud is, the more moisture that gets there, we're going to see lots of heavy rain in these areas. Okay, right where these fronts are staying. Won't see them on the outsides, but right where they're touching, we'll see a lot. Okay. Stationary fronts are interesting. That is when a cold air mass and a warm air mass meet. But neither one can move on the other. This front is going to form. Where the fronts touch, the water vapor in the warm air mass may condense to form clouds, fog, or precipitation. Weather we're going to see, it's going to be big clouds and many days of precipitation. Big clouds and many days of precipitation. Okay. Go ahead and maybe add colors, places if you want. I'm going to highlight our important words now. So when cold air mass meets a warm air mass, but neither one, right, can move on the other, that front's going to form. They get stuck there and they're just sliding back and forth. So where the fronts touch, the warm air may condense to form clouds or other precipitation. Lastly, need to make sure I get my big clouds noted, my many days of precipitation. And we're done with our notes. So now I want you to go through the extension folder, right? Once you've gotten all these notes done in your notebook, We're going to go through the extension folder and explore a little more. Thank you guys. Appreciate.